Good day, miss. My name is Felix.
And my name is Lucas. And today we'll be talking about our building, Torre Reforma, which is located in Mexico City. So starting with the introduction to our site, Mexico City is the capital and largest city of Mexico, as well as the most populous city in North America, and is one of the country's 32 federal entities. So a brief introduction to our building. The building was designed by the architect firm LBR plus A. The whole project area takes up about 73,419 meters square, but the floor plan is only around 40,000 meters square. It was finished building at the year 2017, receiving certifications such as the LEED Platinum and the International High Rise Award. So it's located on Paseo de la Reforma, Mexico City's most renowned avenues. Torre Reforma is part of a cultural, historical and financial district. It is a turning point for vertical urban growth in the megalopolis of Mexico City, having a 2,800 meter square ground site, extremely small for high-rise building, roughly of 40,000 meter square. Next up, I'll be talking about the award-winning system, which is the automatic car park. The carefully planned details for the skyscraper of the superlative also includes a fully automatic parking system bubble here. Below, you can read some of the systems implemented into the car park.
I'm going to talk about the climate analysis of La Reforma. So starting with temperature at La Reforma, the hot season lasts for 5 months, from May 25th to October 25th, with an average daily high temperature above 33 degrees Celsius. So moving to a cool season, which lasts for 2.7 months, from December 6th to February 25th, with an average daily high temperature below 28 degrees Celsius. So moving on, which is the rainfall at La Reforma. So the rainy period of the year lasts for 8 months, from June 6 to February 6, with a sliding 31-day rainfall of at least 0.5 inches. So onto the solar at La Reforma. The length of the day in La Reforma varies over the course of the year. So onto the final one, which is wind at La Reforma. The windier part of the year lasts for 7.9 months, from November 12th to July 7, with average speed of more than 10.8 km per hour. Moving on to the next slides, which we see sustainable features of Torre Reforma. First of all, the building adopts an advanced robotic system which automatically park cars. This will significantly reducing the amount of space and ventilation required for the building. Up next, we see rain and wastewater is 100% reused in the wastewater treatment plant, mainly for bathroom and the air conditioning systems of the building. On to the next one, which is the active chill beam systems. The building adopts the system where it will distribute chill water through coils in the roof panels to cool the office floors. The system will yield up to 30% energy savings in comparison with conventional all-air systems.
Here are some of the overall strategies that we'll be going through today. Moving on to site planning, we'll be talking about the sun path orientation. The overall building is orientated towards the north and south side. The main glass facade is facing towards the south side, whilst the concrete facade is facing towards the north side. In a tropical country, it helps reduce direct sunlight exposure, reducing overall solar radiation and solar heat gain. Next will be the orientation for the windrows. The building is filled with many openings towards the strong windrows to allow wind to flow into and past the building. The position of the tower accentuates the direct view towards the forest and the castle of Chapultepec. The glass facade of the tower turns 45 degrees to face the best views of the city, supported by a 14-meter cantilever over the historical house. Torre Reforma is very known for its strategic location, which is very accessible and well connected to the urban infrastructure and services. Its strategic location is surrounded by important avenues such as the Paseo de la Reforma, Avenida Insurgentes, and the Circuito Interior. At ground level, the sidewalks were expanded around 5 to 7 meters and made accessible for all users, giving priority to pedestrians rather than vehicles. Next up, I'll be talking about building structure and construction. In the diagram, you can see where the parking, the retail stores are, the open spaces / garden, and offices are located within the building. The core in the corner is a concept structure the architects take into account when designing Torre Reforma. In conventional skyscrapers, vertical circulation is typically located at the central core of the building. At Torre Reforma, the elevators and egress stairways are contained in the apex of the triangle. This paired with the long-span pyramidal floor trusses that allow plumbing, electrical and mechanical systems to be concealed within the structure. Construction of the building is complicated since it's set in an area with a long history of significant seismic activity. Because Torre Reforma is triangular in plan, the building has an inherent tendency to twist when subjected to lateral loads and wind, not to mention earthquake forces. Arup, the engineer behind this building, applied a comprehensive time history analysis to establish the performance of the structure under extreme seismic conditions and engineered a solution that is both locally appropriate and consistent with international best practice design for tall buildings. Earthquake proofing is heavily implemented in this building. The tower's use of reinforced concrete shear walls connected by smaller elements called coupling beams help to dissipate the seismic energy. Additionally, on the concrete faces, triple height windows were installed every 4 floors, allowing the walls to bend under stress without breaking. The floor plan of the building has a very uncommon geometry. The 55-story building, distinguished by its triangular form, is composed of two 246-meter high exposed concrete walls resembling the form of an open boat that is closed by a third hypotenuse of a steel diagram over glass. Its shaded facades hung from the diagram allow for versatile column-free interiors and have a great impact on the reduction of energy consumption, representing a remarkable shift from all glass facade aesthetic common to contemporary skyscrapers. So a brief time frame of the construction. In 2010, the historical house was moved 18 meters towards the north where it was placed for 6 weeks. It was moved back so much for the walls of containment for the basement of the building. In 2011 was the construction of the walls in the unoccupied area underneath the historical house. In 2012, the basement is excavated and strained level per level using a top-down method to avoid any collapse of the terrain. From 2013 to 2016, with a self-climbing formwork that brought into the site to pull up the main walls in stripes of 70 centimeters high, and the tensioners are placed with steel to load mezzanine slabs. Lastly, in 2017 was when the building was completed.
So moving on to the HVAC systems, a combination of automated and passive ventilation both moderates interior temperature throughout the structure. The tower's 2 concrete walls also contributes to the energy efficiency of the building. Moving on, the reduction of energy consumption is due to the interplay of the facade and the structural designs. The concrete shear walls work in tandem with the double-layer glass facade and its fixed horizontal shades. Each insulated glass panels expose a single layer of low E glass to the exterior side, with a double layer of laminated glass on the interior. The overall building envelopes generates good energy performance, representing a 24% reduction in energy use against a conventional building of the same size. So up to the next slide, which is lighting. Only one of its 3 sides of the building is open up and allows light into the interior, while the other 2 have few narrow spots where light can pass through. Aluminium screens in front of the glass facade reduce direct sunlight exposure, which allowing the energy efficiency design building to heat up less. The architects place a high value on a sustainable, resource-saving design, particularly in terms of material and intelligent building technology. As you can see, the tower slimness contributes energy efficiency goals by maximizing the use of natural lights to illuminate the interior space.
Grey water system, rainwater collection and water reuse are some sustainable features that can be found within the building. Rain and wastewater 100% reused in Torre Reforma's water treatment plant, mainly for bathrooms and air conditioning. Water tanks dispersed along the tower for more effective local distribution rely on gravity rather than electric pumps, a particularly useful feature in a fire emergency. The building has a primary set of water pumps which deliver water from the basement to a mid-level tank at the 30th floor. The building overall also reduces drinking water consumption by at least 30%. This treated water will serve all street level and low-rise irrigation needs. Currently, Torre Reforma does not use much renewable energy, but there is proposal for the future. Arup, which is the M&E in charge of the building, offered a thermal energy storage system to minimize the electricity consumption during peak times. Other proposed sustainable features include wind power generation. The wind power generation helps power part of the energy grid of the building, and also certain opening allows to control the flow of wind throughout the building, which in turn cool the building down passively.
Moving on to the in-depth of the facade, firstly we're going to talk about the wind flow. Because of the regular occurrence of high-speed wind in New Mexico, Arup designed and engineered Torre Reforma to resist gusts exceeding 100 miles per hour, which is 160 km per hour. Arup uses the traditional cross-ventilation approach on designing the building, in which the wind passes through one location to another. This will improve the comfortability of the interior spaces, while also reducing wind gusts at high altitudes. As we can see, the atria throughout the building that are naturally ventilated to improve indoor air quality and provide occupants with a link to outside. Up next, which is the shading of the building. As the building adopts automated controls to open the windows before dawn, This will allowing cool airs into the building and releasing or exhaling warmer air into the atmosphere. The tower's 2 concrete walls also contributes to the energy efficiency of the building. Unlike glass curtain walls, they reduce the cooling load by protecting the interior from direct sun, without impacting the aesthetic views in the tenant space. So moving on to lighting systems. During the day, the office spaces are well lighted by natural daylight, as natural lightings are evenly dispersed throughout the building to guarantee that the structure satisfies its energy requirements of the building. Up next, which is AI-controlled artificial lighting. All of the building spaces are well lit with high-efficiency LED lighting. Sensors are fitted in each space to ensure that light is utilized efficiently during each specific hours. Into the insulation coating for glass glazing. Building adopts U-value glass insulation, which will provide a 40% to 50% improvement in energy efficiency over double panel glass, with low E and argon, and a whopping 700% over a single panel clear glass.
Now, talking about the exterior layer details. So it's made up of 4 layers with one airbag allowing the passage of a great amount of light without, however, absorbing much heat. Like a corset, they prevent the walls from joining and also to separate and support the mezzanine slabs. So, looking at the right diagram, a huge exposed concrete facade that makes up the main structure of the tower, it functions to transfer all those vertically towards the subsoil. Not only that, but it serves for ventilation, lighting, and as a focal viewpoint. Assembly with double joints mechanic in the event of an earthquake, it works to stop the movement through profiles connected to the concrete walls. Lastly, some sustainable and unique features about this building's facade. The main towers are exposed in situ concrete shear walls with punch windows, following a pattern based on the interior space used. The structure, the ventilation, and the construction process. On the upper floors, the sheer concrete walls give way to prefab glass fiber reinforced concrete panels. On the right, as you can see, the facade, what are some of the gaps meant to be used. The grading on the wall are modulated in stripes of 70 centimeters high. The Tetris-shaped hole gives the wall flexibility to prevent fractures in case of tremor. This repeats every 4 levels and is 3 stories tall. The glass facade system improves the minimum solar coefficient, solar heat gain coefficient, U value, reflection values, and light transmission levels. Other features includes this double facade also serves as an acoustic damping feature. A glass grille protects occupants from wind without obstructing views, but the remainder of the space is open to the elements. Finally, the post-occupancy evaluation. The success of Torre Reforma has shown that skyscrapers can break from the mold of all glass cladding. The prospect of climate change and the wasteful nature of glass facade has challenged architects to pursue a practical alternative, the fortunate byproduct of which is a new aesthetic. Lastly, here's a brief summarized conclusion listed on site planning, building envelope, construction and materiality, lighting system, HVAC system, waste and water management, and facade. Anyway, that's the end of our presentation. We hope you all enjoy it, and as always, have a good day. Thank you.